Maria paints a rectangular wall. The length of the wall is 20.5 meter and the height of the wall is 2.4 meter. Both correct to one decimal place. So these are the rounded figure. This is a wall in which 20.5 is the length and this is the height of the wall. Because these are the rounded figures, these are not the actual figure. So we are not sure which figure is rounded to give this 20.5. So for that we have to find the lower and upper bound of this length. Okay, so because both are correct to one decimal place, so one decimal place is 0.1, and to find upper and lower bound we divide this by 2. So this is 0.05. Therefore the lower bound of the length is, we will subtract this, we will get the lower bound, which is 20.45, and the upper bound is 20.5. In a similar way, the lower bound of this is 2.35 and 2.45. Now we have to find the area of this wall in this question, because 1 liter of paint covers an area of exactly 10 meters square. 1 liter of paint, it covers area 10 meters square exact. Calculate the smallest number of 2.5 liters tin of paint she will need to ensure all the wall is painted. Now because these figures are rounded figure, we don't know what is the exact area of the wall. So we will try to find the minimum area of this wall and the maximum area of this wall. What could be the minimum area and what could be the maximum area of this wall? To find the minimum area of this wall, so we will multiply this length with the height. So for that, when you are doing multiplication, to find the minimum value, we multiply lower bound with lower bound. So to find the minimum area, we will multiply lower bound of the both of the numbers, which is 20.45 into 2.35. So this will give us the minimum area, and to find the maximum area we have to multiply upper bound of both of them. That will give us the maximum area that wall can have. So the minimum area is 48.0575 and the maximum area of the wall can be 50.3475, and this area, using these two figures, the area is 49.2, which is in between these two areas. But the question is, we have to find the number of the smallest the minimum number of tins. To find how many minimum number of tins can be required, so that we are sure that all the wall is painted. We are sure that all the walls must be painted. So when you are sure that all the wall is painted, should we take this area or minimum area or maximum area? Suppose if we take this minimum area, so we are not sure whether the wall will be fully painted or not, because this is not maybe this area is minimum of the actual area of the wall. But if we take this area, which is between these two figures, even then we are not sure the wall would be fully painted, because still we are not sure that there may still leave some area of the wall. But if we take this area, which is maximum area, so here we are 100% sure that all the wall must be painted. But in this case, there is a chance that the area of the wall may be between these two. between these two. So even then, if we use this, so we are sure that whole of the wall would be painted. Maybe some of the wall, maybe we have little bit greater amount of paint. Some paint may be left, but if we use this area, we are 100% sure that all the wall must be painted. But there is some chance that some of the paint may be left. But if we use this area, so there is a chance that the wall may be little bit, the actual wall may have the area greater than this 49.2. But here we are 100% sure the area of the wall cannot be more than this. It can be either equal to this or maybe less than this. So keeping this area in our mind, if we buy the number of tins, so in that case we are sure that the whole wall will be painted. The main question is that we must be sure that whole of the wall must be painted. So we will take this area, which is the upper bound area. Now using this area, now we want to know how many minimum number of tins can be required. Now we do that. 1 liter of paint is exactly covers 10 meter square area. So 1 meter square, 10 meter square require 1 liter of paint. Okay, so this is also meter square. So how much liters of paint is required to cover this area, to paint this area? So by cross multiplication, so it will be 50.3475 divided by 10. So we require this much of liters of paint. So 5.03475 liters of paint is required to paint all the wall. Okay, so 2.5 liters. There are in a one tin there is a 2.5 liters. So let me find how many tins are required. So 2.5 liter is one tin, and this much liters will require how many tins? 5.03475 liters. How many tins? So cross multiply. So again we will divide this. So this is 2.0139. So it means we need two full tin, two full tins, and this is the portion of the third tin. So we need also third tin as well. 2 tins and plus 1/3 tin, one more tin. Okay, so portion of one more tin. Sorry, understand? So we need 3 tins, 2 full, and the portion of the third. So actually we need minimum 3 tins. 3 tin minimum. So if you buy 4 tin, that is okay, but we need 3 tins to paint all of the wall. And out of these 3 tins, we will need the paint of the 2 tins will be used fully, and we will use a portion of the third tin. But from the market, we will buy 3 tins because it is said that we have to find number of tins. So we use minimum 3 tins to paint this wall.